Oh, aren't you good? Yeah, so
Alix, thank you for meeting with us today.
Oh,
and,
Philip.
I appreciate it. We always like to have Power Systems Design, meeting with Intersil to talk about some of our latest technology.
Yeah, so tell me about what Intersil's doing now. Here, I'll even turn this so that everybody can see the logo, straight up in my view. How's that?
Yeah, so today we're actually announcing, it's actually embargoed till the 22nd of September.
Well, I won't release the video until then. How's that?
That's fine. A new part called the ISL 78692. And I will get straight to the point. Basically, this is a single cell lithium ion battery management device. Okay? And it's specifically targeted for the automotive power management space.
Great.
Lithium ion battery systems, single lithium ion battery systems in cars are growing in demand. And it's being driven by legislation in Europe and elsewhere for these emergency telematics systems. So things like the eCal system in North America, the OnStar system, in Russia, the GLONASS system.
Exactly. Very intelligent automotive interactive systems.
Exactly. And they're run off single lithium-ion battery systems.
Right.
Okay. So Intersil is introducing a part that basically solves a lot of the customer challenges that they have when they're designing these eCall systems, these emergency telematics systems. The first is how do you basically have a solution that doesn't drain the battery in the off state? Because if you think about it, a car is actually off probably more than it's on.
Very good point.
and many people store their cars for periods of time.
Right.
You can't drain the battery.
Right. Well, a lot of people then put trickle chargers on their cars in that kind of a storage situation.
Exactly. And this solution actually takes care of those kind of solutions.
Oh, excellent.
But the other challenge they have is, well, the more you drain the battery, then you have to charge it, obviously, and that drives a thermal side of the equation. And they don't have a lot of space in these cars to put these systems. So managing, both the battery life in the off state as well as the thermals is a very important thing. So the 78268 fundamentally is the lowest standby current device in the industry. It only consumes 3 microamps of current in the off state. Okay, why does that matter? Because that's the spec that determines how fast your battery draws.
Right.
Okay, and customers don't want to have battery draw on these things.
They don't.
Right? So this can lead up to a 10-year life in some cases.
Really?
Yeah, 10-year life in the off state, which is very good.
Yeah, but then at that point, you're actually almost starting to talk about using different battery chemistries, like a lithium thionyl chloride battery or something like that for that. If you're talking about that much of a shelf life or that much of an operational life.
For automotive, they've kind of standardized on the lithium ion phosphide battery system. So that's where most of the design is right now. But you're right. I mean, in the future, you could look at other battery chemistries. Our part is AEC-Q 100 qualified, so it's specifically for the automotive space. Temp grade 85, minus 40 to 85 degrees. It's what's called a grade 3 AEC-Q qualification.
Well, frankly, I think eventually all consumer devices need to start meeting those specs because you're going to throw something into a car, or you're going to leave it sitting in the sun, or you're going to. I mean, so many things that happen on a day-to-day basis are aggressive to the equipment as well. I think it's important to have an automotive spec, but I think, frankly, everything should be migrating upwards in reliability and quality and capabilities just to address the hard usage of just a teenager.
Absolutely. If my teenagers are any indication, I would agree with that statement. So the other thing I'll say just quickly on this is that not only does it have the lowest standby current, it also has a programmable current charging control. So basically, you can control how fast you want to charge the battery. Why that matters is thermals. Obviously, the faster you charge something, the more heat it dissipates.
Exactly.
This allows the customers to be able to kind of manage that and get that form factor that they're looking for.
Right. Well, and also sometimes it's off-putting to a consumer to feel the device hot, and they're not quite sure why.
Exactly. I don't know about you. When I plug in my cell phone and I feel, you actually feel the battery and the heat. You're like, I don't know if that's a good thing. And
exactly. So this helps deal with that.
Helps to do that. It also has a thermal protection device on it, a foldback. So, but if it does get too hot, it will actually shut down and safely protect the battery.
Excellent.
Long story short, kind of jumping ahead a little bit.
Well, here, I do want to get a quick shot of this, so that way anybody can pause on this page if they want and actually see this slide. But I see where you're going there. Let's go ahead and skip
that slide right there. Just go to the kind of the competitive section.
Right, there we go.
if you look, this is what I talked about. You have the programmable charge current. Okay, so they can manage how fast they want to charge the battery. It does charge to a
no problem.
It does charge to a 4.1 volt output. Okay, which is really anything above 4.1 volts doesn't work for the lithium iron phosphate chemistry.
Right.
And so this is kind of an ideal solution. If there's other solutions out there that do 4.2 and above, but they won't work specifically for this chemistry.
Got it. Got it. That makes a lot of sense then. Excellent. So what are some of the peripheral benefits? Because the beautiful part about a nice piece of technology is it doesn't just usually do one thing. There are some peripheral benefits in the circuit because of the technology behind it or additional functionality. Are there any other aspects of it that are beneficial to the designer?
Basically form factor. So it's in a little 3x3 DFN package. Okay.
Really small then. Yep.
It doesn't really require very many external components. It's pretty simple to design.
Well, and that's the important thing, because I do note here that there aren't a lot of external components on the device, so it is going to be a little bit easier to do that design in it, which is critical today, because you can have something that's superconducting at room temperature. If it takes you 12 months to design it in, you're not going to get a lot of traction out of it.
Exactly. The other thing is that you can actually charge up to an amp of current on this device.
That's a lot of current.
It's a lot with that current. But what that allows you to do is, if you're designing a bigger chemistry system or a bigger battery system, you don't have to change devices. So you can have one SKU in a system, and it can do your smaller, power packs. It can do your larger power packs, and you still get all the benefits of that nice small footprint.
Right, and the thing about the thermal fold back, you were talking about that earlier. There we go, right there.
Yep. Which protects the device. So I think it's a nice solution. In today's world where you want reuse as much as you can. There's not a lot of time to redesign every platform, in particular in automotive, as the
brand X. No, yeah, competitor A.
Competitor B. Trying to make it generic, but you can see again here. We have the lowest power consumption in the off state, which is called VBAT leakage, and then you can see the current that we can consume, and we're in this little 3x3 millimeter DFN package. So it's a nice device, and I think it's one of many that will come out.
Oh, great! An evaluation board exists. That's good.
We have an evaluation board.
That's always important. I really do feel that design tools are critical, because, as we were saying, it has to be designed in. It has to be developed.
Eval board. You can copy the footprint if you want of the eval board, as well as app notes and full data sheets that are available.
Sweet. Excellent, excellent, excellent. Very nice. Oh, yeah, and here we got a summary.
So, in summary, we think that the device is best in industry in the specs that matter in terms of the 3 microamps of leakage current. It allows the battery to remain active, in the off state for the longest period of time. And it's got the smallest footprint in the industry. So
killer.
We're pretty excited about it.
Well, hey, Phil, thank you so much for taking the time to talk to me today. It was really great. You have a good one now. And Intersil.com?
It is on. It will be on Intersil.com as of the 22nd.
Right. Well, like I said, I'm going to hold on to this until after the embargo date, so everybody will see these dates written all over everything, but it'll be after that date.
It will be after that. It will all be on the website.
Excellent.
Great.
Thanks a lot. I appreciate it.
Thanks, Alix.